Praise be the Lord. Good morning to everybody. I'm recording these classes. I don't know how it's going to be the situation during this week. So that's why I'm preparing this video for you. And this will help us to understand better how will be some of the topics that we need to conclude about the factorization methods. So for this first week, 9th graders, section B and C, we have next objectives. I want to that you at the end of this video understand or finally identify the factorization method to factorize one specific polynomial and then determine the appropriate factorization method. So those are objectives or skills that practically you will win them just by visualizing, analyzing, and concluding what's the best and appropriate way to find or to apply this method. This first part is not gonna be related with the procedure to do. It's more just like to see what do we need at the moment to apply these methods. What are the contents? And if you remember, we start with one factorization method. I think you saw how this works. You did an investigation related with this one. You saw how the greatest common factor, or the GCF, what we call it, works. But right now, there are two other methods that fit in specific situations where greatest common factor doesn't work. Okay, so those methods are the factorization, guess and check, which is related with the trinomials factorization. So the method is called guess and check. And the other is related with special products polynomials. And in this case, we're gonna see it like special products factorization. So we will talk about those. Just let me tell you again, main objective here is just conclude what is the appropriate method to use in a specific exercise. So let's start with the guess and check method useful for trinomial factorization exercise. So we will see how is this, and later we will see now what do we need at the moment to use it, or when it's going to be useful. Essentially, that's what we want. So let's start with this. As you can see here I have a little analysis about how is this method and when it is useful, okay? So here, when we talk about the guess and check method, I will call it a GAC. You can call it like this too. Normally, I like to use a variation for this polynomials factorization. So it works for trinomials, okay, for trinomial expressions. So weird trinomials sometimes, but normally works for quadratic trinomials. I'm gonna show you when it's a weird case. So a rare case probably will be, of course, we will not study something like that, but just because some of you are pretty curious, not like that, is that sometimes expression behaves like next one. Of course, this still being a trinomial because it has three terms, okay? That's something important. That's why I choose this exercise too. You have 1, 2, 3 terms. And of course, this exercise can be factorized by this method, guess and check, okay? But normally here, the exercises we will work just work with x to the second power, working with a degree 2. And that's why we will concentrate more in quadratic trinomials, okay? What are the quadratic trinomials? Are the ones that have 3 terms and the greatest exponent or the degree expression they have is a second power, okay? Or the degree of this expression is 2, like we studied. Something we will set is that this value of A, this value of B, this value of C, not always will be positive, okay? We will see some examples I prepared for you in here. But my observation is that A is a real number, okay? But normally, the same with B, the same with C. The 3 are real numbers, but normally for the cases we will study, we will work just with integers. And if you don't remember what are the integers, let's check those a little bit in the number line, okay? Just little review. If you don't remember, the integers are those numbers who moves in a number line in a positive way what we call whole numbers, but in a negative way too. What we call the negative numbers, right? So all these together, including the 0, are called the integers, okay? Those are the integers we normally used to. Of course, it's not until positive 3, and it's not until negative 3, okay? This goes to till, positive infinite, and this continue, never ends, going on to negative infinite. So here you have like an idea of how it's going to be the numbers that those expressions will have. So we'll show you some examples. Just let me tell you something interesting about it. At a moment to see those exercises, it's impossible to consider a like 0. So this value, this x to the second power will be always there. This is something interesting that will be useful later in other years, probably next year, which is 10. I think it's gonna be useful. So here you have two examples. One example is 3x to the second power plus 7x plus 2. Like you see this example A, it's a quadratic trinomial. Say quadratic trinomial because it has the second power expression and has 1, 2, 3 terms, okay? Something interesting that they were saying is that these numbers, which are called coefficients, excepting for this one, which is an independent term, right? These 3 numbers require this condition or fit exactly in this condition that normally they are integers, positive or negative numbers. The same with example B. As you can see, we have another trinomial, and in this case, a quadratic trinomial, because you have 1 term, 2 terms, 3 terms, and it's quadratic because I have the degree 2. So normally the exercises we will see will be like this. So remember, when we want to factorize, this is something important you should keep in mind. When we want to factorize, the idea is break apart this polynomial into the product of other polynomials. So how this is possible? Yeah, it's possible like this. For example, the factorization of 3x squared plus 7x plus 2 is 3x plus 1 times x plus 2. Something similar happens with this other exercise. Here you have the factorization of x squared minus 5x plus 6, which is x minus 3 times x minus 2. And how I'm sure about it? Okay, I'm sure about it, first of all, because I already know how this method works. I already studied the guess and check method. I already know how that works. I already know how can apply GAC. But what I need right now is that you identify when is going to be useful. So 2 simple conditions. You're gonna have a trinomial, a complete trinomial, of course, and that trinomial will be a quadratic trinomial. So if you see those conditions in one polynomial, think in the guess and check method, okay? And probably your question right now is, how can I reach this factorization? Okay, this will be related with a puzzle game I designed for you. And the idea of this is just remember a little bit the multiplication tables. Multiplication tables of the numbers you study in earlier grades, okay? So, and something else. If you don't remember the factorization, this is something that I'm gonna do just to check. I'm gonna check letter A. How can I be sure that 3x plus 1 times x plus 2 is the truly factorization of this trinomial? Because again, and I'm gonna repeat this many times because I wanted you to lose the idea of the factorization. Factorization requires that you represent your polynomial, okay, the exercise we have right now, like the multiplication of other polynomials, but those polynomials must be like in the simplest way. And essentially, this is what we have in here. So, how I'm sure that this 3x plus 1 times x plus 2 is the factorization of 3x squared plus 7x plus 2. Okay, I'm going to do the multiplication for you. In that case, you will see that the product of those multiplication I have right now, because this is a factorization, we did it with numbers, I remember. You gave me the idea of decompose. Those words you used were nice. Here, let's see if this truly will convert into this expression, which is 3x squared plus 7x plus 2. So that's going to be 3x squared. I mean 3x times x is 3x squared. 3x times 2 is 6x. Then we go with the 1. We already distributed the 3x. Now we have to do it with the number 1. So 1 times x, in this case it's positive 1, it's positive x is going to be positive, and the product of 1 times x, which is just x, or if you want you can write the 1x, but I think it's already understood that here is just 1x. Okay, then we multiply the 1 times the positive 2, which results in positive 2. Okay, so we're almost done. If you forget the idea is that the product of those, the multiplication or the result of this multiplication will be 3x squared plus 7x plus 2, and I think this is what we have. If you see, we have the 3x squared. Those are like terms. I mean 6x and x. Those makes 7x and plus 2. So it's true. This is the factorization of this expression. Of course, this is not something that I am asking you to do if you're clear with how the guess and check method works. But again, right now, what I need is that you understand that this expression fit in the guess and check method. Okay? But there is something sad about the guess and check method, and is that not all the trinomials can be factorized by guess and check. This is something important you should keep in mind, and it is because the exercises sometimes, I mean, you can create many quadratic trinomials however you want, but sometimes those cannot be factorized inclusively, not by guess and check, by any method. They cannot be factorized because they behave like this. So I hope that if you have a question in next class, we will start with those. I have a little activity and a little homework related with this identifying the method. Okay, it's missing one more, because at the beginning I told you that we will study the trinomials factorization, which in this case fit in the guess and check. But now we will see the special products. How's the procedure with the special products? Okay, and here is our next method, which in this case is related with the special product cases. If you don't remember what are the special product cases, I have a little review for you right now with those ideas. So the PST, I remember pretty good what means PST. When we study this, we call it like the perfect square trinomial. There is an important word in here. That one, trinomial. Okay, when we work these exercises, we have the multiplication in this way, and because some special product exercise, then you just develop the exercise applying this formula and you solve the multiplication without doing many procedure or other process like the distributive property, like I did it in this exercise when I checked the factorization of the trinomial. Okay, I mean, you can avoid that if you work with special product. But here's something important, because the word right now is not going to be multiplied to see what happened. No, we will have an exercise and we will convert it into a multiplication. Okay, it's like thinking backwards. So interesting, this of factorization with polynomials. And here the important word is this trinomial. Okay, and of course it's something we already studied. So at the end, this special product, which is the perfect square trinomial, will fit into a guess and check exercise. Why? Because the exercises we will see will behave like this one. And if you see this expression we have right now, it's a trinomial that has 3 terms, and at the same time has the degree 2, so it's a quadratic trinomial which fit exactly in what we describe of the guess and check method. Okay, because normally it works for quadratic trinomial. So essentially, this is a singular case of the guess and check. Doesn't mean that there's no other way to solve this one, just that it has something interesting. Just gonna show you one, and what's the little difference. For example, here you have the 2 factors of this trinomial. The factorization is 3x plus 1 times x plus 2, which at the end, yeah, is the way to represent this 3x squared plus 7x plus 2, like the multiplication of other polynomials. But if you see here, they are different. So what's the new thing at the moment to do this factorization method? I mean, the procedure will be the same. That's something we will conclude later. But what's going to be the factorization of this expression? So here it is. And essentially, the difference is that here, because you have this second power, if you say it differently than the other exercise, is that you repeat the factor twice, okay? And that's the curious thing of this. At the end, you will see that solve an exercise of the special product, the PST, will be solve one exercise of the guess and check, just that have something curious. And is that you're gonna repeat the factor. You find that's why we're gonna show it like you have it right now on the screen. Not like this, x minus 5 times x minus 5. Because you're multiplying twice the same expression, you will leave it like, or write it like, x minus 5 to the second power. So the special product, perfect square trinomial, doesn't require many procedure to is just a special case or a singular case of the guess and check we have been studying. Okay, let's talk about the other one. The other special product we study is the difference of two squares. Something interesting here. You will see why. So here we have the dots method, like I like to call it. And the special thing here is that normally in this exercise, you don't work with trinomials, okay? This is something new. You will work with binomials. And essentially, still being quadratic binomials is gonna show you why. Here is one example of one dots exercise. As you can see here, you have the multiplication of two conjugate expression. And we normally have exercises, we did exercises like x minus 2 times x plus 2, then apply the formula of dots and conclude the answer, which is something that we will not do now. I mean, we will have something different. We will practically start from the answer and convert this answer into the multiplication. Because again, what is factorize? Is show your polynomial like the multiplication of other polynomials in the simplest way. So here's a little example. X squared minus 9 require a different procedure than the guess and check, which you saw that will be useful in these special product cases too. Here, some people and some teachers too teach this one, including this one in the guess and check method, but I don't really like it, and probably I will teach you this how it is, but not too common to see it, okay? Because you have to convert this expression into a trinomial then, which is a little bit weird, but not impossible. We will see how is that, and look how is the factorization. If you see, this expression looks a lot like this one. I mean, here you have the x squared, which behaves like the a squared, and then you have this 9, which is behaving like b squared. Probably not. You will say, because you didn't have the second power thing in here. But if we concentrate and we analyze that these 9 at the end is the same path, 3 times 3, which is exactly 3 squared. So essentially, we already have b squared, right? So they behave like that. And that's something that we will see later, how to do that factorization, how that method works, okay? But right now, again, I just want that you identify what's going to happen. So essentially, at the end, we're going to conclude how to identify those. I've been teaching you this, not how the method works. That's going to be later. Right now, I just need that you identify when the method is useful. So here is the factorization, and as you can see, like I told you, we're gonna convert this expression into the product. So essentially, it's like go backwards of the work we have been doing. And finally, here is the factorization of x squared minus 9. So procedure here is not complicated. Procedure here is pretty simple and just require that you apply some techniques that we will see later, okay? Probably here you will remember a little bit how the square roots work. Okay, so try to remember how square roots works, because this is going to be useful. Inclusively here, I will teach you the other way to understand the special product, the perfect square trinomial special product, factorization, which is better, I think, to see it like a singular case of the guess and check. Okay, here we have a little match exercise, which will require we determine what exercise fit in the factorization method of the greatest common factor, as you see it like GAC or GAC, if you want to call it like that, no problem, and difference of two squares. And why I'm not talking about the special products And like that, because I told you here, I can summarize this pretty quickly, that this perfect square trinomial will be a singular case again of greatest, of the guess and check method. So at the end, we will study just two more factorization method, like I told you the first time we studied this of factorization with the greatest common factor. If you remember that at the end, we will study just three cases, three different and interesting ways to factorize expression. So I will give you, or I will ask you right now to pause this video, okay? Stop it just for 1 minute and try to match with lines, okay, these specific exercises. If you see, you have 1, 2, 3, 4, 5, 6 exercises. So pause the video right now and I will give you, or take 1 minute to do the exercise. Okay, so we will see the answers. I hope that you did it your own. In this case, the first exercise, as you can see, 2x squared minus 5x plus 2, it's a trinomial because you have 1, 2, 3 terms. And of course, because you have a second power expression here, it's a quadratic trinomial. So this is related with the guess and check method. Okay, next one works just with 1, 2. So it's not a trinomial. So essentially, for that reason, you can say, okay, it's not a guess and check exercise, which is okay. But let's analyze why this one is dots, because it's dots is true. First of all, it has two terms. It's a binomial, okay? That's why it's called a difference of two squares. Something interesting is that both expressions have exactly square root, and you can look for it. Square root of 4x squared, which will be 2x, and the square root of 25, which will be exactly 5. So that reason, and the other situation is that they are indifferent. I mean, it doesn't exist the addition of two squares. Be careful with this. It's difference of two squares. This works with the dots factorization method we will study later. What about the letter C? Letter C is another trinomial, as you can see. And it's a quadratic trinomial, okay? So here it is. A guess and check exercise. I mean, yeah, cannot say that the dots exercise first is not a binomial like the letter D. As you can see, letter D, x squared minus 16, it's a dots exercise, and of course, both expressions have some exact square root. The square root of x squared, I will explain you then why it's just x. But then the square root of 16 is exactly 4. So I think this exercise fit in the method of dots. And the last one, the last two exercises, one has something curious, okay? This letter E, for example, is a trinomial, and of course, it has something interesting. We'll see later. We can take those exercises down to explain you the methods, how they work. But right now, I think you already identified that a guess and check exercise. Reason, it's a trinomial and has the second power expression. So the last one, which is totally different, to be honest, of what I mentioned in here. Probably you already discover what method will help you here. If you think in dots, because you have two expressions, which makes binomial, and is in subtraction, that's not enough. Remember, I asked you to get the square root of those expressions, okay? And the square root of 5x squared is not exactly. It's not an exact number. And they must have an exactly square root. The same with square root of 10x and something else. If you see the 10 halves the variable x, but it doesn't happen the same in the other two exercises we identify of dots. So what's the method that works for this exercise? The method that works in here is the greatest common factor, okay? And this is something I need that you keep in mind because it's very important. That's why I need to conclude everything about this factorization we will study in general. I mean, we have been studying this method. Now it's going to be this the time to study this this guess and check method and the dots. Okay, we will see how that works. But do not forget this first factorization method. It's too much important. So I will ask you to practice again this factorization method, the greatest common factor, and how I know that, okay, first of all, this is what you have to do. Here is the recommendation, so check this out. Here is like a conclusion of the factorizations method we will study, okay? And you will see why it's so important that you keep in mind what I'm saying, okay? Do not forget these greatest common factors. This is one of the basic and important factorization methods. And I recommend you something. So if the factorization method consists in to write a polynomial expression like the multiplication of other polynomials in simplest form, you have to consider next. There are three methods we will study. Of course, at the end is just the greatest common factor, we already see. The guess and check, we will study, and the difference of two squares, okay? So why I'm presenting you this? Because at the moment to solve one exercise, this is what you will do. You will explore first and see if the polynomial contains the greatest common factor, because if it's like this, then the exercise simplifies a lot, okay? Once you simplify, once you get the greatest common factor, then you will see if the remaining expression, okay? Because if you remember, when we work greatest common factor, can I show you with this exercise right now? We have in here 5x squared minus 10x has a common factor. I think you can get it pretty quickly because 5 and 10 and the same table is 5. And if you see here we have x squared, but here we have x, so at least we have an x in common. And the factorization will be not 5x squared because I'm taking out a 5 and an x. It's just an x missing. And the same in here, 10x, not 10 because I'm taking out an x, so will not be x over there. And the 10, because 10 is 5 times 2, at the end here will be reminded. So what you will do then is explore what happened in these other parentheses if you already get the greatest common factor in one exercise. And that's why I have it like this. First of all, identify if you have a greatest common factor. If you have it, then check if the remainder expression is a guess and check or a dots expression, okay? So if the exercise doesn't have greatest common factor, is the turn of the guess method. We apply it, of course, you will see if it fits over there. And remember, at the end, this special product, that perfect square trinomial, will follow the same procedure as the guess and check. You will see that this guess and check is going to be like the master key to solve many exercises. Of course, I think that now you're sure when you're going to apply the guess and check method, which for this reason, I record that class, okay? So please review a little bit more this class, do it your own with the last exercises we identify. I'm talking about these ones. And do not forget this important idea. To factorize a polynomial, first look for the greatest common factor if it have it. Sometimes doesn't have it. If not, then go with the guess and check method. And finally, if guess and check doesn't fit, because sometimes you will not work with quadratic trinomials, see if the difference of two squares special product, or in this case, special technique to factorize, will help us to conclude the exercise, okay? But there is a homework related with this. It's pretty simple. Will consist in to do something like we did in the match exercise. It's in your hands to finish it, and we will see then how to apply the guess and check method and the dots. That's everything for today. Thank you for your attention, and you can see this video many times, okay? Have a nice day. Bye-bye.